Okay, now, good morning everyone. We have discussed about the rate of reaction. Today we will discuss about units of rate of reaction. Okay, so today we are going to know about the units of rate of reaction. Rate of reaction. From the definition of rate, from the definition, by definition, we know that rate equals to concentration upon time. So in simple language we can say that unit of rate is concentration time inverse. In simple language we can write concentration time inverse. Okay, now if we want to take the concentration in the terms of mole per liter, if we take the concentration concentration equals to mole per liter, then unit of rate will be mole per liter upon second. Then that means mole per liter per second. So this is the unit of rate. So if we have a gaseous reaction, then for gaseous reactions, we have the concentration of gases in the form of partial pressures. So concentration in terms concentration of gases equals to in the form of partial pressure, that is known as ATM, atmospheric pressure. Now then it will simply, the unit of rate will become ATM upon second, and simply we will use ATM second, ATM we will use simply, okay, we will use simply the ATM, just 1 minute, yeah, we will use ATM per second. So this is the unit of rate for a gaseous reaction, and this is the unit of rate for the simple reaction if you have given. Okay, we are using mole per liter per second for the any reaction if the concentration is the mole per liter, and if the concentration is in the form of partial pressure, then its unit will be ATM per second. Now let's see how we can relate the rate with a given chemical reaction. Suppose consider we have a reaction Hg in the form of liquid plus Cl2 gaseous. We are getting HgCl2, HgCl2 gaseous form. Now we want to find this rate of reaction for this reaction. Okay, then rate of reaction rate equals to simply we have decided we have decided that we will put the concentration power to the in the denominator and time in the second. So for this is reactant and this is product. So we know that for the reactant we use minus del R upon del T. So for this reaction, especially for this reaction, it will form minus del Hg upon del T. Okay, and now this rate must be equals to minus del Cl2 upon del T, and that must be equals to del of Hg, this is square bracket HgCl2, this whole upon del T, because here the rate forward must equals to rate backward. It means the amount, the rate at which the rate of the rate of disappearing disappearing of reactant must be equals to rate of forming product. So this is basic concept here. This is the basic concept here. That means rate of disappearing of reactant must be equal to the rate of the forming of the product. If these both rate are equals, then we can say that a reaction is finalized and that reaction is valid. Okay, and this is the definition of rate. Okay, similarly we can write, suppose we are taking one another example. Let's change our color. We are taking the example to Hi gaseous in this form H2 gaseous plus I2 gaseous. Now if you want to write the rate for this reaction, then rate equals to minus 1 upon 2 del Hi upon del T, and rate this rate this rate equals to plus del of H2 upon del T, and that equals to del of I2 upon del T. You may wonder that why we are using here is minus sign. Here why we are using minus sign. Why we are using minus sign. So let's know this answer in next slide. Significance of minus sign. Okay. Significance of significance of minus sign. Minus sign just indicate the amount of reactant is decreasing. Minus sign indicate amount of reactant is decreasing. Whenever there is decreasing rate, when there is a decreasing rate, we will use the amount of reactant is decreasing, we will use minus sign. That's why we are not using the minus sign in the product form. You can see here we are not using the minus sign in the we are not using the minus sign in the this. You can see del of Hg Cl2 upon del T, not minus del Hg Cl2, because we are getting the product. If we are getting the product, that means amount of product is increasing. So if there is rate increasing, then we will not use any minus sign. Where there is a decrease in a rate for any type of reactions, or you can say in general for any purpose, if the rate is in decreasing, there should be a minus sign. Okay, so this is the concept here. Okay, now if we want to move further, then we have two questions and we have to solve. This is the NCERT question given in your textbook, that is known as in text question, and it is given that for the reaction R to P, the concentration of reactant changes from 0.03 m to 0.02 m in 25 minutes. Okay, now let's move to the numerical. Move to the numerical. That is question. Here R2P is given, and R1 is given. R1 means the rate at initial rate, you can say 0.03 m, and R2 is given, that is equals to 0.02 m, and time del is del T is given 25. So first of all, we know, and it is asking about the average rate in terms of minute and